In this example, we're going to investigate the end behavior of a polynomial. So we're given the function g of x equals x minus 5 cubed times 2x plus 1 times the opposite of x minus 1. And we're asked to determine the degree, the leading coefficient, and the behavior of the graph as x approaches positive and negative infinity. Alright, let's consider the degree first. So if we look at just this first factor with the cube, if we were to multiply this out, the highest power of x that we would see would be an x cubed. Then we have to take that x cubed and multiply it by this 2x and this opposite x. So by the time you multiply all of this stuff out, you're going to get an x to the 5th term. As far as the leading coefficient goes, well, this would have a leading coefficient of 1 on the x cubed when you multiply it all out. Take that x cubed times the 2x, that's going to give us a 2x to the 4th, and then times another negative 1x. So we're going to end up with a negative 2x to the 5th. So the highest degree term that we're going to end up with is a negative 2x to the 5th. So that means the degree of g of x is 5, and the leading coefficient is negative 2. So now we're able to analyze the end behavior, because since the leading coefficient is negative and the degree is odd, we know the left-hand side, the left tail, will go up to positive infinity, and the right tail will go down to negative infinity. So in symbols, we would write g of x goes to minus infinity as x goes to minus infinity. So again, as we get larger and larger negative x values, we get larger and larger positive y values. And as x goes to positive infinity, g of x goes to negative infinity. So again, as we get larger positive x values, we get larger negative y values.